We have already looked at hypothesis testing through the analogy of an American courtroom. Part of that analogy is the collection of evidence. To draw a conclusion for a statistical test, the evidence comes partly from what is known or believed to be known about the population and from the sample data. When the sample data looks like the population is expected to, there is nothing more to be done. Studies get interesting, however, when the sample data gives us reason to think that the expectation about the population couldn't be true. That's where the p-value comes in. This is the definition of p-value as found in the textbook. It starts out simple enough. The p-value is a probability. The rest of the definition is where it gets fuzzy. We need a couple more vocabulary reminders before we try to make sense of the p-value. The null hypothesis is a statement about the population that will be considered true until there is sufficient evidence to doubt it. So far in your statistical education, populations are assumed to have their data values distributed symmetrically, with most values near the center and a few values far to the right or left. The null hypothesis gives us the value for the center of this graph. If that statement about the population is true, the sample value would be unlikely to be at one of the far ends of the population distribution. Let's start with a specific example to illustrate what all this precise statistical jargon means in the definition of a test statistic. This is the t-statistic for the mean. The numerator is the difference, the sample value minus the population value. The denominator is the standardization, the standard error which combines information about the variability of the data with the size of the sample. The standard error gives us a measuring stick for how far or near a value is to the center of the hypothesized distribution that was pictured on the previous slide. You can see the video choosing a test for other examples of test statistics. They all share the same format though. The notation and complexity of calculation depend on the particular test. Now back to our definition of p-value. When our test statistic suggests that the sample data is far from the center of the population distribution that is described in the null hypothesis, it can be marked on the graph in one of the tails. The probability of getting another sample that would be even farther from the center of this hypothesized population distribution is quantified as the p-value and illustrated by shading the more extreme areas. The smaller the p-value, the stronger the evidence that the null hypothesis isn't true.